All right, guys, here's our first section of notes, pre-calculus 0.1, and you can see it's a real numbers, o en español, números realidades. We got some good essential questions here. So how do I translate from English to math? Like I just translated from English to Spanish. We'll work on some translating from English to math. I actually think of math as a language, and so it's a universal language that everybody in the world uses, so it is valuable to be able to translate to it. Next up, how can I use interval notation to show a range of numbers? So that's kind of the big thing I would say from this section is interval notation. Okay, so next up here, we'll start with some examples. So we'll translate from English to math. And so we'll write all of these as an inequality. Now, what's an inequality? Well, an inequality, that's like when women didn't have the right to vote. No, just kidding. That's a little history joke for you there. But in math, when we're talking about an inequality, we're talking about one of these guys. So we'll be using at least one of those in every single one of these questions. So I'll start off here with number 1a. And it says y is less than 5. And so this one is actually kind of a direct translation. And so I can just say y is less than 5. And that symbol in the middle literally means less than. Now, another thing about inequalities is that it's actually always the case that there's two different ways to write them. And so I'm going to go ahead and put or here. And I'm going to write it like this as well. And so we can also write this as 5 is greater than y. You can see that that means the same thing as long as I switch that inequality in the middle. I think of it like if I say I am taller than my brother is shorter than me. So if y is less than 5, that means that 5 is greater than y. So two correct answers to that question. Okay, next up, the next one isn't a direct translation. It's actually a little trickier. So the next one says z is positive. So for z is positive, I'm going to have to think, and if I kind of think about on the number line, what's the border between positives and negatives? Well, if I think about it like that, I would say, if I made kind of a number line here, and then these are all the positives, and those are all the negatives, well, that border number right there in the middle, that has to be 0, right? So if z is positive, that means that z is greater than 0. It can't be greater than or equal to 0 because 0 itself is not positive, but it is greater than 0. Now, I cannot say, let me show you a wrong answer here. So I'm going to cross this off after I write it. This is not right. If I said z is greater than or equal to 1, the issue with that answer, because it's mostly correct, because you think about that, it could be 1, 2, 3, 4, or 5. But what about decimals, right? So what if I had 0.1 or 0.5? Those are positive, but they're not greater than or equal to 1. So my original answer here in the blue is better. All right, now once again, though, we can write this a different way, but that would just be switching the order here and saying 0 is less than z. Next up here, we have b is at least 3. And so for this one, I'm going to say b is greater than or equal to, oh, it was negative 3. I said 3, but it meant negative 3. At least means this number or above. So at least that phrasing in English is kind of always referring to a greater than or equal to. We do have a phrase in English that means the less than or equal to, and that phrase is at most. So if you ever see that phrase at most, that's going to be a less than or equal to. And then once again, we can write this the other way. Negative 3 is less than or equal to b would mean the same thing. I can switch the order as long as I switch that inequality in the middle. Okay, next up here. W is negative and at least negative 7. So right away, I see that we have that phrasing again, at least, and I know that that's going to refer to a greater than or equal to. But then we also have negative, so I know that's going to have something to do with 0, since we talked about earlier, 0 is kind of the border between positive and negative. So in this case, I'm actually going to put W in the middle here. And I'm going to put negative 7 over here, and I'm going to put 0 over there. And I know I want, let's see, I know I want W to be greater than or equal to negative 7, but since it's kind of backwards, it actually has to go this way. because negative 7 is less than or equal to w, means the same as w is greater than or equal to 7. And then negative w would have to be less than 0 to be negative. The other trick on these ones, if you kind of cover up the w here, and you think between negative 7 and 0, which one's bigger? Clearly 0 is bigger than negative 7. And so both of the alligators, as I call them, as every third grade teacher calls them, should open up to the 0. So that's a good trick on these, where the variable is in the middle. Take away the variable and think about which one of the two numbers on the outside is bigger, and both of the inequalities should open up to that one. Now, once again on this one, we can write this the other way around with 0 over here and negative 7 over here. And that would just mean switching these inequalities. And so now you can really see that w is greater than or equal to negative 7 right here, like we had said back there. All right, last one here is even trickier still. Oh, let me put an or right here. And so this one, it says the distance between 3 and p is at least 5. And so whenever I think about distance on numbers, distance is always subtraction. And the reason distance is subtraction, if you think about it, if you think about, let's say p was like let's say this p right here was a number instead of a letter. And let's say this p was 10. So what's the distance between 3 and 10? Well, logically, you know that that's 7. But if you really think about it, that's a subtraction. So what I'm going to say here is I'm going to say p minus 3, and it at least is greater than or equal to 5. But this actually isn't quite right yet. And the reason it's not right, like I said, if p was 10, this would work, right? 10 minus 3 is greater than or equal to 5. But if p was a big negative number, if it was like negative 5 minus 3 is not greater than or equal to 5. But the distance is at least 5, if you think about that on the number line. So what we do here is we throw some absolute values around here. Because distance, the other thing about it is that it's always positive. And so absolute value, we know, turns everything positive. And so if I say the absolute value of p minus 3 is greater than or equal to 5, that is now referring to the distance. So I'm going to say that's going to be my answer right there. Now, technically on that one, there's a lot of different ways to write it. I'm going to write it one more way. If you wrote that as the absolute value of 3 minus p, if you switch that order around, but kept that as 5, that actually still does work, because like we said, like p minus 3 p minus 3 and 3 minus p are the same thing if they're inside of an absolute value. All right, next up here, we're going to talk about interval notation. Some of you may have used this before, maybe not, I don't know. But so interval notation is just a way of writing a range of numbers using parentheses, and I'll just draw my parentheses there if a border number is not included, and brackets, so I'll just draw brackets here, when it is included. I always, and we'll get into this chart here in a minute, but I always have these two drawings I always draw, so maybe you want to draw these over here. And these two are what I call the faces of inequality. So it's like Susan B. Anthony. No, just kidding, that's another history joke there. But the first face of inequality is a less than and a greater than. So that's like we're seeing here on the first problem. And that is always shown with parentheses. So that's like his mouth there is the parentheses. And then we also make his nose as an open dot. And so we'll be showing that right there. All right, so then the other face of inequality is the or equals to. And that one is shown on the number line graph as a closed dot, and that one has brackets. So I always kind of keep these two guys separate here. Everything within the same face is connected. So if we're using the less than or greater than, we're going to be using an open dot, and we're going to be using parentheses depending on which form we are on here. And then same thing goes for that face. Okay, so first up here we have an inequality, and I wanted to address this up here first, the x and then this little line. This means that x can be anything given that a is less than x is less than b. So this is really what we're going to be focusing on right here, is the more important piece on all of these. And then that first piece is kind of just an extra kind of unnecessary piece. I wanted to show it though because sometimes it does show up, and so don't get freaked out by it. Okay, I'm going to do this on the number line graph first. That's what I mean by the graph. So here we have from A to B, and I think you guys are pretty familiar with the number line graph. Now these ones are going to be open circles, and it's going to be connected between two open circles. So our interval notation here is going to be from A to B, and it's going to be both parentheses because they're both open circles. So you can once again see this whole face being used on every piece here. So then for the next one, the interval notation is in brackets. So that means when we're doing the number line graph, that is a closed dot. And then when we're doing our inequality, I'm not even going to put that x bar thing. I'm just going to put A is less than or equal to x is less than or equal to B. All right, so the next up here, are you allowed to have one bracket and one parentheses? The answer is yes. And so are we allowed to have one bracket or one closed dot? One closed dot and one open dot? The answer is yes. And so sometimes that will happen. In fact, quite often it will happen. So we have a bracket A with a B and then a parentheses. So you can see it still matches up there. That the A is the closed dot, so that has the bracket, and then the B is the open dot, so it has the parentheses. All right, next up here, we have this one's going from A to infinity and beyond. No, just kidding. That's for you Toy Story fans out there. So for this one, I'm going to start it here at A. I'm going to have an open circle because it's a parentheses there, and then it's just going to go right forever. I'm not even going to put B there. I'm definitely not going to put, you could put B if you wanted, but definitely don't put infinity. You're actually never going to put infinity here, and you're actually never going to put infinity over here either. The only way you would use infinity is in that interval notation. The reason why you don't need infinity on the number line graph is because if we draw that arrow going right, that already means that it goes on forever. So it's not like it gets to infinity and then stops. It just keeps going. All right, so then for the inequality, we're just going to say x is greater than a. And so I don't need to say it's less than infinity. Kind of everything is less than infinity, so I'm just going to say it's greater than a. So it's kind of a one-sided inequality there. All right, next up here, x is less than or equal to b. So this one I'm going to have my number line. I'm going to have b here with a closed dot, and that's just going to be going left forever. All right, so then in the interval notation, now very important on the interval notation, it must always go with the smaller number and then the bigger number. And so B is not the smallest number here. B is actually the biggest number, so I'm going to put that second with a bracket. So what's the smallest number? Well, it's not 0. It goes to the left of 0. It's not negative 10. It's not negative 100. It is actually negative infinity. Because, and is there a negative infinity? Yes. I mean, you learned first that there was a 5, and then you learned that there was also a negative 5. So now I'm telling you that there's also a negative infinity. Now, something you may not know here is that on the infinity and negative infinity is always parentheses. So I'm going to make that note up here next to this face. Is that infinity and negative infinity are always going to have parentheses around them. I guess the reason why on that is that the bracket implies that it gets to that number and stops there and includes that number. We're not really including infinity or negative infinity because it's not really a number. It's just an idea that it goes on forever. So that's some important stuff to know about interval notation. So let's practice applying it here. All right, so we're going to write the following in interval notation and graph. I actually like to do the graph first, so I'm going to be doing that on all of these. So the first one here, it just says that this is going to go between 3 and 7, and this one's going to be a closed dot. That'll be an open dot, and it's right in between those. So for my interval notation, it's going to be a bracket 3 and then a 7 with a parentheses. Number 3 here, we're going to start at 3 with an open circle going left. And then for our interval notation, whenever it's going left forever, it's always going to start at negative infinity and then go to 3 and go to whatever the number is. If it's going right forever on the number line, it's going to start at that number and then go to infinity. If it's going left on the number line, it's going to start at negative infinity and go to that number. So that's why I think it's always easiest to draw it on the number line first. Okay, so then this one is going to go from 6 to 11, a closed dot there and a closed dot there. So bracket 6, comma 11 bracket. Okay, next up, number 5. So once again, I'm going to draw this on the number line first. So we got negative infinity with a closed dot and then going right forever. So as the inequality, I'm just going to say x is greater than or equal to -5. Remember, we don't use the infinity for any version other than the interval notation. So I should not have that in my inequality nor my graph. All right, next one here, we're going to go from -2 to 0, both of them open dots. And then I'll draw it here, put the x in the middle. And then I just always do my trick of both of the alligators are going to open up to the bigger one. Now 0 is in fact bigger than -2. 0 is bigger than any negative number. All right, last up here, -1 with a closed dot going left forever, which means x is less than or equal to -1, and we should not be using negative infinity on our inequality.